Hi, welcome back to the power of model drawing. Now today we are going to look at primary 6 model drawing lesson, and we're going to look at a very wordy problem again, and how do we make the problem easier to solve. Right, the first example, we will convert the percentage into fractions. So how do we actually make a problem that is hard to become easier? Now if you see the problem has percentage, right, you can convert the percentage or change the percentage into fractions, and then the fractions will become like a normal, then the whole problem becomes like a fraction problem. And then you can use the fractions to draw the model. Alright, so let's look at example 1. Alright, and we are going to highlight the keywords and the numbers. Happy Town had a circus performance during the school holidays. 20% of the people were performers and the rest were audience. Female performers were twice the male performers. 60% of the audience were male, and there were 1,200 more males than female, right? After some males left the circles, so you have to change there. Something happened, right? So you have change. What do you mean by change? It means that it's going to be a before and after problem. Like, so whenever there's a change or there's something that happened, then this problem will become like a before and after problem. So after some males left the circles, what happened in the end? What happened in the after? 20% of the remainder people were male. So how many males left the circles? So this whole problem is a before and after. And so then you need to ask what is unchanged. So there are 4 answers. Is the total people unchanged? Or is it one group unchanged? Or is it difference unchanged? Or everything changes? Well, in this question, you have only males who left the circles. So the females are unchanged. Okay, so this is quite simple to answer the question, right? The females unchanged. Okay, so how do we break down the problem and draw the model? So you convert the percentage into fraction. So 20% is 20 over 100, which is 1/5. Okay? And then 60% is 60 over 100, which is 3/5. Alright, and then you have 20% again, and that will be 1/5 again. Alright, and then let's draw the model. So Happy Town had a circus performance. So if you think that you don't know how to draw the first sentence, then you skip and go to the next sentence. 1/5 of the people. So what does this fraction refers to? It refers to the people, right? And what happened? You break up the fraction. The people has 5 boxes and 1 box were performers. Okay, so let's draw the model. So you draw a rectangle, cut into 5 boxes, and 1 box were performers, and the rest must be audience. Okay, so you draw the sentence already. Now, female performers were twice. Twice means 2 times the male performers, which is 1 time. Alright? Then you look at the model. Where are the performers? Isn't that your 1 box here? 1 box of performers. And the female performers is 2 units, and the male performers is 1 unit. Add together, you have 3 units. So the performers have 3 units. And then when you cut 1 box into 3 smaller boxes, do the same for the whole model, which is very important. Cut the whole model equally. And then you can start to label. So this 1 box, right, will be the male performers. Let's call it MP. And then the next 2 boxes will be the female performers. Okay? Alright? And every box is called 1 unit. Alright, now continue reading. Now there are 3/5 of the audience were males. So the fraction 3/5 refers to the audience. So how do you know what the fraction refers to? The whole fraction refers to the noun, alright, the words behind, which is the audience. And then you break up, the audience has 5 boxes, and 3 boxes were males. Alright, then you look at the model. So the audience are supposed to have 5, right? 5 boxes, but you look at the model, you can see the audience has many boxes. So how to cut it into 5? You can't. So whatever you cannot cut, then you drop down, right? Drop down what you cannot cut, and now you can cut into 5 boxes. So 1, 2, 3, 4, and 5. And 3 boxes were male audience, right? Male audience, and of course the rest must be female audience. Alright? Okay, and then where are you? You're until here already. Now, there were 1,200 male audience than female audience. Oh, we can actually do something already. If you look at the model, you can see the female audience has 2 units, the male has 3 units, so you can find how many units more. So as you draw the model, right, you will be able to find the next step, right? You'll be able to connect to the rest of the problem. Alright, so let's connect to 1200. So the male is more than the female audience by how many unit? So 3 unit minus 2 unit, you have 1 unit more male audience. And 1 unit more male audience is also 1200. Am I correct? And you can find many things. You can find how many male audience, which is 3600. So you put down 3600 male audience. You can also find how many female audience, which is 2 unit, and that will be 2400. And you can put down 2400. All right. Okay, and not only that, you can also find many more things. You can find how many performers are there. And how do you find how many performers? Now, you look at the audience. So how many people in the audience are there altogether? Which is 5 units. So 1200 times 5, and you have 6000 people in the audience. So the model will guide you what to do. And then you can work backwards, right? Work backwards to find how many is one tiny box. Alright, so you work backwards. You can see the audience is 6000, right? And that will be how many parts. If you count all these tiny boxes, all these are parts. Why I don't call units? Because they are different. Okay, so you can see how many parts of audience. So there are 3, 6, 9, 12, right? 3, 6, 9, 12 parts. So there are 12 parts of audience, which is also 6000. Then your one part will be 6000 and divide by 12, that is 500. And then you go to the performers, and can you see that there is 1 unit of male performers, which is 500. Okay, let me use a black color. So there are 500 male performers, and there are 2 units of female performers. Mr. Tong should not put the units, should be parts. Okay, let me just, okay, parts, right, there's a writing error, parts. Okay, so there's 1 part of male performers, which is 500, and then there are 2 parts of female performers, which is 500 times 2, that'll be 1000. Okay, so you have 1000 female performers. Alright, now you can see that you have all the important numbers. Right, so let's recap. Now, male audience, 3600. Female audience, you have 2400. The male performers, you have 500. And the female performers, you have 1000. Alright? Okay, now we can solve already. Now, after some males left the circles, so the females didn't leave the circles. So the females are unchanged. Then 1/5 of the remaining people. So this fraction refers to the remaining people. Right? So how to draw the model? You break up. The remaining people has 5 boxes, and 1 box will be males. Okay, so let's draw another model. So it's okay to draw a few models just to show out the problem. So the remaining people in the remaining people will be how many boxes? 5 boxes. Am I correct? And 1 box were males. Right? After some males left, you only have 1/5 of the remaining people who are males. And of course, the rest will be females who are unchanged. So can you find how many females are there altogether, which is unchanged? So you look at the female performers, which is 1000 female performers plus 2400 female audience, right? And you will get a total of 3400 females. And these 3400 females are unchanged. Right, no females leave the circles, and there will be 4 boxes, right, in the after model. So this is your after, right, like your after model. Okay, so you take 3400 and you divide by 4, right? 3400 and you divide by 4, and what do you get? You will get 850. Okay, 850. So let's put down. So you have 3400, 850, 850, 850, 850, and the males is also 850. Okay? Okay. Alright, so what do we do next? So how many males leave the circles? Alright, now, can you see that you have 850 males in the end? Alright, these are the number of males in the end. So can you find how many males at first? You look at the female performers, look at the male performers, and you plus the male audience, which is 3600, and you have 4100 males. at first. And then you take 4,100 mils at first, and you minus how many mils in the end, which is 850, and that will give you how many mils who left the circles. So 4,100 or 4,100 minus 850, and you will have 3,250 mils who left the circles. And that's how you solve these 4-mark, right, 4-mark problems. All right, so what is the lesson here? Now the lesson here is, if you see percentage in the problem, you can change the percentage into fractions, and then the whole problem becomes like a fraction problem, and you look at the fractions and draw the model, right? And it's okay to have a few models. Sometimes you may need to draw a few models to help you to show out the problem. And as you draw the model, you find that in the process of drawing, you are able to connect to the rest of the problem, right? Somehow the model will be able to guide you, all right? As you draw out the model, it will guide you to connect to the important numbers in the problem, and that's how you work out the rest of the steps through the model, all right? Okay, now let's go to example 2, which is a 5-mark question, and it's a little very wordy. All right, so let's read and highlight. Jerry wanted to buy a pair of shoes. During a sale, he saw a white pair of shoes on sale at 50% discount, and a black pair of shoes at 20% discount. Both pairs of shoes were selling at the same price before the discount. To buy the white pair, Jerry will need $2.50 more than what he had. Jerry bought the black pair of shoes and had $2 left after that. How much did the white shoes cost before the discount, and how much money did Jerry have at first? All right, now some of you who are very good in maths, then you ask Mr. Tong, I know how to do. I don't want to draw the model. That is also fine. All right, if you know how to draw, then if you know how to solve, then you just go ahead and use your own steps. All right, write your own steps, use your own method. But this is more for those students, right, who are weak in your maths, you're not so good in your maths, and you are unable to solve, right? You don't know how to even start or where to start. Then my advice is you draw out the problem, and then you will know where to start. So for those who are good in your maths, you know how to start, and you know where to start. Then you just go ahead. So how do we start, and where do we start? All right, now we draw the first sentence, all right, and you look at the first sentence, and there's nothing we can draw, so we skip. Now, during a sale, he saw a white pair of shoes and a black pair of shoes. Now, in this example, I need to show you that when you draw your model, you can't draw too small. All right, if you draw too small, you find that usually you will have to erase and draw bigger because you don't have enough space to put down the information onto your model. So you always have to try to draw a bigger model. Of course, you don't have to draw very big, right? So draw not too small, but don't draw too big. Just nice for you to be comfortable in putting the numbers there, right? Because you need to put numbers onto your model. So you don't want to squeeze your numbers. You don't want to squeeze any words. So draw bigger and draw longer. Okay, now he saw a white pair of shoes on sale at 15% discount. So this model that I'm going to draw is called a percentage model, because you don't see Mr. Ong cut into boxes, right? That is your bar model, your normal model, all right? When you draw fractions, you cut into boxes. But in this model, I just put percentage onto the model. So that's why I call it a percentage model. I don't cut into many boxes, all right? You will see me put the percentages onto the model. Okay, then what happened? He saw a white pair of shoes at 15% discount. So there must be a usual price, which is 100% original price. And after 15% discount, so let's cut this 15% discount. He only has to pay 85%. Am I correct? Okay, that is the money he paid, which is after discount. And then he also saw a black pair of shoes at 20% discount. So I cut a little bit longer, and he only paid 80%. Now, why are the two rectangles the same length? Because both pairs of shoes were selling at the same price. So you draw two equal rectangles, right? They were selling at the same price before discount. So which means that both rectangles are sold at 100% each, okay, at the original price. Okay, now, so where are we now? We are until here. Now, to buy the white pair of shoes, Jerry needs $2.50 more than what he needs. So which means that he doesn't have enough money to buy the white pair of shoes. Okay, so what do we do? So I'm going to draw Jerry's money. Okay, Jerry's money. So how you want to label is up to you. So Jerry's money, okay, is until it has to be shorter, right? Shorter than the white shoes. that is sold, that is after discount, right? For example, he needs the money to buy the white pair of shoes, right? But he doesn't have this money. So you should not draw the rectangle until the dotted line. You should draw until somewhere, all right? Somewhere near the dotted line. And so you can see the short of, there's a shortage there. So that shortage there is not enough, right? Not enough. So which means that he doesn't have this money, right? This money to buy the white pair of shoes. Okay, so let's tidy up a little bit. Okay, let me just, okay, and be prepared to do adjustment. If you find that your model is not very clear, then you may need to do some adjustment like what I'm doing, right, to make it look nicer. So Jerry needs $2.50 more to buy the pair of shoes, so I can't put the number inside. So I just be creative, right? You can draw an arrow and point to the box, the dotted box, to show that he doesn't have enough money. Okay, and then what happens? So with that money, he can buy the white pair of shoes. So did he buy the white pair of shoes? No, he didn't. He bought the black pair of shoes and had $2 left after that. Okay, so it means what? It means that he actually went to buy the black pair of shoes. You can see that, wow, that's the the money that he has, right, to buy the black pair of shoes. And there's this leftover box, that is your $2 left. Okay, now I find it very squeezy. So what I would like to do is I would like to do some adjustment, because it's too squeezy already. So this is what you may have to do in your drawing, right? Sometimes you find that the model is too squeezy, right, or it's too small. Then what must you do? Then you go and tidy up your model. You go and erase some parts of the model, right, and then you just draw again. Of course, you don't have to erase everything. Just draw out those parts where you need to fine-tune, right? You need to adjust. So I'm going to adjust this 20% and just make it a little bit longer so that I don't have to squeeze, right? How about here? Okay, that'll be nice. All right, so do your own adjustment. All right, and then this 20%, all right, you can put it in the middle, right? 20%, okay, 20%, and I think this $2.50, the shortage, the dotted box is a bit too small. Then what do? Then just do your adjustment, right? Because if you can draw clearly and properly, right, then you find that it's faster to solve the problem. So I'm going to show the shortage box even more clearly. All right, so let's draw until, okay, so where's the shortage box? Okay, over, so where's the black box? Right, the black box. Okay, so all right, so let me just draw this part. All right, he has enough money to buy the black pair of shoes, and he has what, $2 left. Okay, $2 left. Okay, all right, let me just adjust again. All right, okay, hang on. Okay, so let me just okay, so okay, let me just do some erasing. Okay, now we can continue. Okay, all right, so now he doesn't have money to buy the white pair of shoes, so which means that okay, he only has this money, because he doesn't have enough money to buy the white pair of shoes. He needs $2.50 more. But he has enough money to buy the black pair of shoes. Why? Because after buying the black pair of shoes, he still has $2 left after that. Okay, so that's how you draw the model and make it look nicer. Okay, let's recap and let's relook at the model and revise. Now, okay, let's revise the model from the beginning again so that you are not lost. Now let's look at the first sentence. And Jerry wanted to buy a pair of shoes. During a sale, he saw a white pair of shoes at 15% discount. So can you see the discount? So which means that he only paid 85%. So the original price is 100%, which is a very special number, right? Your usual price, 100%. And he also saw a black pair of shoes at 20% discount. So he doesn't have to spend this 20%. He saved 20%, right? Discount means you save. So he only spent 80%, right? And both shoes were selling at the same price, so before the sale. So you can see why I draw two rectangles of the same length, because both shoes, they are sold at the same price, so equal rectangles. Okay, and to buy the white pair, Jerry will need $2.50 more. So which means that Jerry doesn't have enough money, right? His money is until here only, right? He doesn't have enough money to buy the white pair of shoes. He will need until the dotted line to buy the white pair of shoes. So he has $2.50 shortage, right? He's short of $2.50 to buy the white pair of shoes, right? So he doesn't have enough money to buy the white pair of shoes. But he has enough money to buy the black pair of shoes, because when he buy the black pair of shoes, which is how much after discount, which is here, right? So he has money to buy the black pair of shoes, and after buying, he still has $2 left after that. So can you see the $2? Right? So he has $2 left after that. So this is the leftover, and this is the shortage or the shorts. He doesn't have this money to buy the white pair of shoes. Okay? So how much did the white pair of shoes cost before the discount, which is your 100%? And how much money did Jerry have at first, which is to find the green color rectangle, right? And your model is done. So you can see it takes a while to draw the model because you need to adjust, fine-tune, do some erasing on some parts of the model to make it look nicer. But you can see that when you draw the model, it is never perfect. So first time you draw, it doesn't look clear. Then you may have to erase and just fine-tune the model drawing. Okay, so let's now continue and look at the model and solve. So if you look at the model, what do you see? Now, can you see the 20% discount, right? And the 15% discount? If you take 20% and you minus 15%, that will give you how many percent? That will give you 5%, right? 20% minus 15%, that will be 5%, right? And then how much is 5%? That will be $2 plus $2.50. Okay, so your 5% is $2 plus $2.50, and that will be $4.50, which is 5%. Then can you find 1%, which is 90 cents? And how much is the white pair of shoes before the discount, which is 100%? And so you take 90 cents times 100. The white pair of shoes cost $90 before the discount. Alright, so you got your part A already. Alright, so you can put down $90. Okay, then can you find how much money he has? Yes. So how do you find? Now, you can find how much is 85%. Alright, so 85% will be 90 cents times 85. And that will be $76.50. So which means that the white pair of shoes cost $76.50 after discount. Alright? And then how do you find the money that he has actually? You take the cost of you take the money that he needs to buy the white pair of shoes, right? But does he have the money to buy this white pair of shoes? He doesn't have. He is short of. Short of what? Short of $2.50. So he doesn't have enough money to buy the white pair of shoes. Then how much money does he have actually? So you minus $2.50 and you will get $74. So how much money does he have at first? He must have $74 at first. Okay? And that's how you solve the problem. Right? So this is $74. Alright? So you can see that if you draw the model well, sometimes the steps are not many. Sometimes you can see that you can actually get the answer quite fast because of your model drawing. But the most important thing is to be able to draw out the model and then take time, right? Take time to build your model, to draw the model, and to be as clear as you can. What is a good model? A good model is when you show someone the model, right, and then the person is able to use your model and to get the answer without even have to read the question. So that is how you should be drawing the model, right? If your model is not clear, and how do I know it's not clear? When I look at your model and I can't do anything with your model because many things are missing, then it is not a clear model. But a good model is when you actually draw out the whole problem, the numbers are all inside the model, and then after that somebody look at your model, right, and then and study your model, and then from your model, the person is able to come up with the steps, that is a good model, right? The model shows out the solution. Okay, all right, so we come to the end of this online lesson. So stay tuned for the next online lessons. So you will see that in every lesson that we are doing, we always touch on the very hard problems. But in all these hard problems, what is the most common method that we can always use to solve is always model drawing. All right, so stay tuned to the next lesson.